Hello, this is Sadashiv Fadnis, Product Marketing Manager for Rubidium signal generators here at Anritsu. In this video, I'll be talking about generating a CHIRP using User Defined Modulation Option in Rubidium. Rubidium supports many standard analog modulation schemes such as AM, FM, PM, and pulse. It is also possible to enable a combination of modulation schemes simultaneously. This video will show how to create a CHIRP using user-defined modulation option by enabling internal FM and pulse modulations simultaneously. In the previous section, we saw the CHIRP signal in frequency domain. In this section, let's look at CHIRP in time domain. Okay, so now we are going to change this frequency to something that our oscilloscope can accept. So I'm going to set it to say 10 megahertz. And we are going to leave the output level there 0 dBm at the same level, and then we are going to go back to the modulation. And if you remember in the previous section, we had this we had the ramp set to 1.25 kilohertz, and we had the pulse width set to 800 microseconds, so we haven't changed any of that. Now the only change I have done in my setup is because my oscilloscope also has other limitation, which is it can only accept 2 inputs. It's a 2-channel oscilloscope. So if I want to see the CHIRP in time domain, I have to connect the RF output of Rubidium to this oscilloscope to the other channel. So what I will do is I will replace the input that's coming from the ramp, the baseband ramp input that I had fed into the oscilloscope. I'm going to replace that with the RF output. And then you should see the CHIRP in the place of ramp. So let me do that. Okay, I've done that, and now I'm going to refresh the scope display, and here you go. So in place of the ramp, now you are seeing the CHIRP, right? So this is your pulse, and synchronized to that is the CHIRP in time domain at 10 megahertz. Now let's also make some more adjustments and see if this CHIRP repetition frequency, let's say if we change the width, the CHIRP width, whether it changes. Let's say if we change the pulse width, whether the duration of the CHIRP also changes, because that is what we want, right? So let me go back to the pulse and go to pulse width, and instead of 800 microseconds I'm going to set it to 500 microseconds. And remember always that you are going to readjust your ramp period to the reciprocal of that 500 microseconds, which is 2 kilohertz, in order to get the deviation that you want, the deviation within the CHIRP, right, that you want. So I've set the rate to 2 kilohertz, and now let us refresh the display cycle, the oscilloscope display, and there you go. So you got smaller CHIRP width now, and you could make it even smaller, just like what we had done in the when I had shown you the signal in the frequency domain. So let's suppose I go back and change the pulse width to only 250 microseconds. Okay, so that's 250. So you have a much smaller pulse width. Let's look at that. Let's refresh those. So you have a much smaller pulse width. Your chirp width also got reduced, but then you have much lower, you're going to have much lower deviation within this. So if you want to get back your original deviation of 2 megahertz, then you go back and you change your rate, then you are going to get your 2 megahertz deviation. So you change your rate to reciprocal of that 250 kilohertz, which is 4 kilohertz. Sorry, the reciprocal of 250 microseconds, which is 4 kilohertz. And then go back and refresh your display, oscilloscope display. So now you got your full deviation, right? So this is what the signal looks like in the time domain. This is what the chirp looks like in the time domain. So with Rubidium, you can adjust any duty cycle you want, which will adjust your pulse, your chirp width, and your chirp on and off periods, right? You can this is how you generate a chirp using or by simultaneously modulating FM and pulse in Rubidium. Now the question is, why do you want user defined modulation option enabled in this one? Now you need user defined modulation in order to do this synchronization between the chirp or the ramp which generated this chirp and the pulse. So with that synchronization, you are going to always start your chirp at the start of your pulse, So that is why the user defined modulation option is needed.